Thank you, dear participants. So we are done with our day one. So snacks are available outside. So and tomorrow again your session will start at 10 o'clock morning. So same venue here you need to join at quarter to 10 like that. Morning we have two sessions and afternoon again 2 to 4 we have Hansel session in EC department labs. So and whoever did not carry their hospital
based on that you can make it and it will be work as a ground truth. So you have the exact ground truth and you have the predicted output. You have to map that one. So if you have received 90%, that is you have matched. Suppose 80% you have matched, 70% you have matched. So the possibility will vary. This will be identified by related algorithms. So whatever the algorithms we are using, based on that related outcome will come. So sometime that one algorithm will provide best result, sometime it may fail. So depends on the what kind of data we are using, nature of the data. Then based on the problem statement we are using. So here problem statement that would vary. That role of AI in power system. If you are talking about, so AI is revolutionized power system with real-time insights and automation to improve the particular power efficiency. So operational efficiency, we can reduce the energy loss, we can optimize the resource allocation, and another factor sustainability. So we have to support renewable energy integration and carbon emission reduction. So our concern is to understand that sustainable development means to just we have to understand how much time we are using carbon reductions and how we can use the sustainable energy. So application of AI in power system forecasting. We have to predict power demand, energy productions, optimize. We have to understand the various algorithm. That algorithm will responsible to for understanding of load balancing and smart grid efficiency. Third, fault detection. So we can identify the potential failure anomalies, that is early to predict the breakdown. Control and automation. So we have to enable the dynamic voltage regulations, demand side management, and renewable energy integration. So we have to integrate renewable energy through AI. So AI will help smooth integrations, variability of renewable energy sources. Finally, AI promote the development of self-healing grid. As I said, self-diagnosis, self-healing, self-improvement. That will be repair, self-repair for particularly faster outage recovery. So power demand forecasting we can do by AI. That means we can do how power forecasting will be there with respect to artificial intelligence. So AI will predict the electricity consumption pattern. What is the pattern of Warangal? What is the pattern of Hyderabad? Then in the different area of the Hyderabad, we need to predict the pattern of electricity, and based on that, we have to take the historical and real-time data. Why forecasting important? So forecasting, because ensure that grid must be stable. Grid must provide the electricity in the properly. Otherwise grid failure will take place. So we have to understand the stability by preventing overproductions or underproductions. Reduce the operational cost by optimizing the energy production schedules and help to grid operators plan for peak load periods and seasonal. That is the power demand forecasting. AI technology for demand forecasting. That means we are using regression models. So various regression models are available that use for linear or no linear regression model between past and future energy demand. As well as example, multiple linear regression techniques are there that we can use energy consumptions based on temperature, season and historical data. That means you may get it 1 year of data from Warangal city, Warangal urban, Warangal rural. With respect to data will be there for 5 grids are there and how many users are there. So one side you have data in terms of temperature will be there. So January temperature will be different, June temperature will be different, November temperature will be different, and with respect to season also vary, with respect to demand also vary. So March, May, June and July the people will use more AC, air conditioner people are using more, but October, November, December less. So consumption will be less. So demand also will be less during that time. So that is the factor we are going to determine. Same long short-term memory network, LSTM network. LSTM also will be divided to GRU and other types. So type of RNN is specialized, that is working for time series data. So whatever time series data, so practical lab will be there to analyze the time series data forecasting. So here capture the complex pattern and long-term dependencies. We can predict the hourly people are using particular power or daily what they are using and whatever the seasonal demand will be there. Same time auto regressive model we are using, that is a popular statistical model, short-term forecasting. That means short-term forecasting that we can do with the help of this algorithm and effectively for capturing the trends, seasonality in historical demand data. That means whatever the demands are required, based on that we can predict it. Similarly, real world examples. That means utility companies was using AI model for accurately predict the weekdays, weekends, what is the demand patterns are there, we can prepare for extreme weather event. Likewise, benefit of AI in terms of forecasting. So we can minimize the energy wastage. We can prevent the overloading on the grid, as facilitate the better planning for energy, renewable energy integrations and when peak load requirement will be there, and help to reduce the particularly overall electricity prices. The prices of electricity we can reduce by applying of optimizing energy procurement. So related to same way we can use predictive maintenance, that is the another technology through AI in power grids. So you can see here AI will identify the early signs of equipment failure. That means once equipment is going to failure will take place, we can early determine, we can early detect them. So by using of analyzing the sensor data, various sensors equipped with the grid, we can identify this at that this time the grid failure will take place and what is the possibility will be there. So technology is anomaly detections or identify the irregularities in equipment and behavior. Then we can improve the reliability and particular thermal imaging, like detect the overheating component, that means sometime component will become overheat. So you have to provide the like temperature balancing through AC and other coolant requirement. Same thing, vibration analysis. Vibration also will be important because various mechanical parts are there, mechanical issues are there. That will be the turbines and motors, they may fail. So we have to predict them. So what is the benefit? Reduce the downtime maintenance cost and extend the lifespan of grid component, as well as we have to manage the reliability, as I said, and safety in the grid. So reliability and safety is one of the important parts. We can ensure that provide the predictive maintenance. We can predict the maintenance is required or not. That is the possible through AI. Load balancing using machine learning. So we have learned machine learning. So we have the particular small base station, macro base station. How the people are using mobile phone and power requirement is every case. So more phones, more power requirement. Power management is very important. So if the power management is not there, so this particular tower will fail. So how this particular states will be identified, sensing data will be given to the neural network. Neural network consists of multiple layers. They are responsible to extract the pattern, extract the feature, based on that predict an action. So change the load condition here. So that local data will force to the whatever the condition will be there. So here AI will help to distribute electricity efficiently across the power grids. Neural network and reinforcement learning, as I said, reinforcement learning means we are predicting whether we are correctly going or not. If it is not going, we can modify with the agent, interacting with the agent. So that learning predict the demand in real time. So AI will manage peak load balancing to prevent the grid may go overloading, or demand response management for optimized consumptions. Benefit energy cost saving, reduce the power losses, as well as improve the grid stability. We can improve the grid stability, and consumer must satisfy. So consumer satisfaction also one of the requirement. So all this way machine learning will manage the load balancing. Smart grid optimization, as we have seen various renewable energy resources, how grid, macro and smart grid will be designed, how we can optimize them. So smart grid is a modern electricity network. We are using digital technology. Digital technology improve the grid's flexibility, reliability. What is the role of AI? It will modernize the grid system. AI will modernize the grid system. So smart grid optimization, IoT integration, Internet of Things. So I said from the last 10 years, IoT will take part. So entire system will be integrated with internet. And if internet, without power, no use of internet. Every device require internet. In this room, if you are using all things require power. Without power, no devices are working. Okay, so like that, IoT integration means after 10 years without internet, you cannot survive. After 20 years, that means reliance on internet will increase. So we can say AI role in the smart grid optimization, IoT integration. We are collecting real-time data from various sensors, various smart meters. So every home, every house, there are smart meter will be there. A smart meter will collect the energy data. Continuously it will monitor. So in the city, if there are 25 lakhs houses are there, 25 houses, total 25 lakhs meters are there. So 25 lakhs meter will generate the data that means per house, per meter, almost 200, 150 average reading will be generated. So that means how to connect the sensors there and how to collect the data. And data analytics, we have to process the large volume data. So 35 lakhs into 100 GB. So it will become big data. So large volume data from the grid data to identify optimization opportunities. So various optimization algorithms are there. Okay, we have to optimize them. And based on that, self-healing networks. The network may fail anytime, so self-diagnosis activity will be provided to the system for predictive maintenance. So here, automatically we can detect and isolate the faults where fault has occurred to minimize the outage duration. Similarly, energy storage optimization. So as we are using nowadays, that means electric vehicle, that is also became very popular. Almost, if you'll see, the particular people have started to purchase electric vehicles. So that is the growing day by day. So AI ensure that efficient charging, discharging of the battery storage system. So these are the main benefits when we are using AI in terms of smart grid optimizations. It will reduce the transmission lines losses and operational losses, enhance the grid resilience against particular cyber attacks and natural disasters, as well as facilitate the renewable energy integrations and micro grid management. So you can see the smart grid how we are using in particular areas, house, hospitals, industry, various places, how renewable energy resources are also generating power. All these are the factors we can optimize with AI. Now AI for fault detection. So what is the fault detection? Identify the and diagnose the fault in power system. So any device will be there, you have to detect the fault and prevent the major disruption. So AI technique will utilize deep learning, utilize computer vision, utilize rule base. What is computer vision? Analyze the image from the drones to see that anomaly detection or detect the damaged power lines. So somewhere we cannot go, what we will do, will provide the drone, camera will sense the line has damage or not by the computer vision. And we have to utilize deep learning. So deep learning identify the whatever the anomalies happened in terms of sensors reading, or we can predict particularly fault locations also. And rule based techniques which are responsible to determine the thresholds for the whatever the threshold of the voltage that will be there, whatever threshold for current will be there or temperature will be there based on the rule based technique. Or we can detect the abnormalities, we can detect the faults, and we can diagnose. And self-healing that technique will be applied through the rule based technique. So AI techniques, particularly fault based, related to deep learning, related to computer vision, and related to rule based techniques. These are the main technology we are using. Now what are the benefits? That means it will provide the faster response times, and it will just handle particularly reduce the repair cost also. As I said yesterday, reliability factors are very important and it will go like a bar term. So initial endogenous stage and last wear out failure. In between constant failure will be there. And based on the mathematics, we are going to identify the failure rate of the device. So after the wear out failure, you will not go for repair of the device. Device will be repair not possible. So you can replace the device only. So that means we have to understand, reduce the repair cost. So repair cost will be there under constant failure rate time only. Or initial day, if the device has suffered from some fault or some, we can diagnose them. That is a possible. So likewise, we can prevent the cascading failure. We can prevent the widespread backlogs and improve the whatever the grids technique, whatever the grid we are using, improve the overall grid stability and whatever the safety will be required. So reinforcement learning, particularly for grid stability. So as I explained, reinforcement learning is another kind of learning that we are using, particularly for in AI approach, where agent will learn optimal grid control strategy. That means interaction will be there by agent and identify what is the optimal requirement of the grid will be there. So we can provide the control strategies through the trial and error. An application is we can go for voltage control. What is the voltage control will be there? Maintain the grid voltage within the limit, safe limit. We have to maintain the frequency regulations. That means whatever the balances generations and consumption will be there. Basically these are required for avoid the frequency fluctuations and dynamic load management. That means that is very important because we have to understand, we have to adapt what is the power flow will be there. That is the main requirement. So adapting is the one of the mechanism of deep learning. We can adapt as per the whatever data will be generated. So adapt the power flow in real time manner as well as to match the whatever the grid condition we desired. That is the main important part. So similarly we can see here benefits. So far we have to reduce the human intervention and provide automation. Mainly we are working for that. That's why we have introduced the AI, we integrated AI and improve the system adaptability. So system must be adaptive. Certain changes will come, automatically system will learn based on the parameter and will integrate into the system. As well as enhance the grid reliance and reduce the downtime. So all this can be done by using of reinforcement learning and we can make the grid stable. Now renewable energy forecasting. So previous lecture we have learned about whatever the sources are there. So AI role, that model basically predict the what is their solar energy will be there, what is their wind energy production will be there, what is their weather forecasting will be there, and what are the historical data will be available. Based on that we have to predict, forecast it. Similarly, techniques, neural network capture the no-linear relationship between weather and power output. What is the weather? What is the power output? Same time series model. So forecasting future energy generation, how much energy we can generate, that pattern also we can predict by using of time series model based on the historical data. Benefit of renewable energy forecasting, improve the grid stability, same renewable energy integrations. We can integrate the more and more renewable energy integration, as well as reduce the reliance on fossil fuel based on backup power. So we have to avoid the carbon footprint, reduce the carbon footprint, or we have to just reduce the reliance on fossil fuel. Based on this, these are the benefits are there. Energy consumption prediction model, that also we can do with AI. So AI will predict the energy, whatever the smart energy consumptions will be required, consumer energy will be required based on the pattern for better demand planning. So application, smart thermostats, that is the sensors we are using. For appliances, what we are using, optimize the energy based on the AI recommendation. So AI recommend that like a bulb. Now this you'll see what kind of bulb now is inverter bulb coming. You'll see inverter bulb. So the inverter bulb we integrate the AI. That means that integration will provide the this kind of technology. They will recommend how much time they have to just provide the energy, what are the timing will be required to charge, whatever the timing this will be discharged. So utility based on AI forecasting for energy pricing and load management, that also we can use it. That is the energy consumption prediction. So how many energy will be consumed, that prediction model also will be developed. AI for power outage detection, that also we can do by using of real-time grid monitoring, by using of geospatial analysis, or by using of customer support. So in real time we can detect the outage, we can predict the potential causes, and geospatial we can map the outage location, we can provide the faster response time. And finally customer support, AI chatbots as we are using nowadays. Now we are not going to call to the customer care like Amazon. There is a one chatbot will be there, just you typing message, one robot will come. The robot will just take your query and will connect to the customer support and then provide the your just support only. So customer report outage and provide real time update also. That will be done by the chatbot. So this is the AI powered outage management we are doing. What is the importance for forecasting in terms of power system? So forecasting basically involve the how predicting of future power demands. In future how much power is required in a particular city. As I said in that session, our system are increasing day by day. Our appliances are increasing day by day. So our power requirement also increasing. So that we have to predict. So future power demand and energy productions using historical data we need to work. So that is the main requirement. So benefit, particularly we have to work on grid stability. That means we have to ensure that whatever the balance demand is there, and we have to supply to avoid the particularly blackouts. Cost optimization, and cost also must reduce because it helps to schedule power generation efficiently and reduce the cost. Renewable energy integration. So we have to integrate, mitigate the variability of solar and wind energy trading. So here we have to improve the prices strategies, whatever the energy markets are there, and particularly application point of view, whatever the demand planning, peak load management and energy storage, that must be optimized. These are the main part of forecasting in power system. So time series analysis for power forecasting. What is time series analysis? So a method to determine the trends, to determine the seasonality, and to determine the pattern of data which we have generated through grid. So in this case, these are the trend analysis will be there. We have to understand what is the long term pattern will be there in energy consumptions. What is the pattern of Warangal in particular season? That pattern is common. So based on that, we have to understand the trend. Same, we have to understand the seasonal decomposition. So we can recognize the whatever the recurring pattern will be there based on the seasonal demand spikes. Similarly, we have to understand exponentially smoothing. That means reduce the random fluctuations or for clear patterns. And use case, particularly it is required for daily and seasonal demand forecasting to plan the energy production. So how much energy need to be produced particularly for Warangal urban or particularly for Warangal rural. Similarly for nearby cities. So likewise we'll see that irregular fluctuations. These are cyclic, these are trend, these are seasonal. So likewise this data which we have collected from the last 10 year or historical data, it will be analyzed by time series. So time series will be provided as a method to identify trends, to identify seasonal conditions, to identify the pattern. That is time based data. Time based data means last 10 year. That is time based data, and that can be solved by machine learning. So in terms of regression, in terms of classification, in terms of predictions. So we can see the regression model for linear forecasting. So model that linearly, like that means interrelationship will be there. So we can say model that relationship between demand and one factor, temperature only. What is the temperature and whatever the demand will be there. Same multiple regressions use several variables that for forecasting accuracy, day of the week, time of the year, season, many things are. Polynomial will capture the non-linear relationship. It was linear, it was for complex load forecasting. So benefit, we can easily implement, interpret, and what is the short term forecasting. That means related to short term forecasting it effectively for small data set. That means when we are having near term predictions, we can use this one. So we can see that data will be available in terms of mean temperature. This is the data in spring, fall, summer and winter. What is the peak load will be there? What is the peak load condition will be there? So based on these models we can utilize. So linear regression will provide the one factor only, temperature. Multiple regression will tell multiple factor, day of the week, day of time or year, or polynomial it's a non-linear. We will capture the non-linear data like a complex load forecasting. And what is the benefit? It's very simple and easy to implement, and we can implement. And short term forecasting effectively using for small data set and particularly near term predictions. So this is ARIMA for power demand predictions. So what is this? This is the completely statistical model. Basically this model combining the historical data, trends and past errors also when we are going to forecast. So here auto regressive for particular looking past observation, and I is differentiating or whatever the changes are there in data pattern, and MA is moving average for considering the error terms. So we combine these techniques. So in this technique what we have observed, this is the statistical technique. So component auto regressive, this is the using past values, whatever the past values are there for future prediction. By past value we are going future, and I integrated value differencing to make the data stationary. We are doing differencing. And third, moving average. We are using the past forecasting error for adjusting. By that way we are adjusting the data. So commonly used short term energy demand forecasting. This is the applications. Benefit, it's very effective for capturing the seasonality and trends in historical power data. So we may get it seasonal data, we may get it trends of historical power data by these techniques. LSTM network, it's a one more popular deep learning architecture basically utilized for time series forecasting. This is the architecture, LSTM, long short term memory. It's a deep learning model designed for capture long term dependency in sequential data. So advantage in terms of power system, it's very helpful in power system because it handles the complex pattern of energy consumptions data, and it's very effective for forecasting or predicting with larger data set and time dependency data, because here it's one memory part will be added. So capture the, in any sudden demand change will be there in long term trends. So with respect to renewable energy forecasting, we can forecast renewable energy by using of this network. We can use peak load prediction by this network. We can use real time demand, whatever the real time demand will be there for 2026, 27, that we can utilize. Similar way, machine learning based energy price forecasting. We can do the energy price. Purpose is in future what will be the price of energy will be there. 2030 what will be price will be there. 2035 what will be the. So it help to grid operators for energy markets, technique decision tree classifier, support vector machine classifier, neural network classifier, basically application energy trends optimize, peak or price predictions, and financial planning. So decision tree capture the no linear data between price and influencing factor. SVM classifier will the pricing trends for accurate predictions, and neural network utilize larger data set for high accuracy price forecasting. And particularly application we can identify the energy trend optimizations, peak or price predictions, and financial planning. These all three things we can manage. Now AI in renewable energy forecasting, we can utilize AI for whatever the renewable energy resources are available. So challenges with respect to renewable energy source like solar and wind, highly variable due to the weather change. They are dependent on weather. So in winter, we cannot use solar that much level. So likewise, solar energy use the historical data, weather predictions to estimate the solar output. So in summer, what will be the solar output will be there. In winter, what will be the solar output will be there. In terms of rainy season, what will be the solar output will be there. We have to predict. Similar way, wind energy, analyze the wind speed pattern to predict the turbine output. So in winter, what will be the turbine output? In summer, what will be the turbine output? So hybrid forecasting model will combine AI with the statistical model for high accuracy. And benefits, improve the grid stability, optimize the renewable energy integration. So like a same directions, we can use the weather predictions for energy management. So we can get the role of weather. Weather is very important because it depends various parameters like temperature, wind, sunlight directly affect the energy demand and renewable output. So AI techniques provide the weather data integrations. We can merge various real-time weather data, particularly for accurate energy forecast, and deep learning model. So deep learning model basically we can learn with respect to data for weather pattern, and also we can predict the extreme condition. There are multiple use cases are there, like forecasting temperature spikes, whatever the data we have collected, and basically it is required to prepare for increased air conditioning use. When you want to use air conditioner, which duration you want to use, how much time you want to use, that you can predict it. So likewise, forecasting temperature. So in summer, AC is required. In winter, AC is not required. In a rainy season, AC is not required. Likewise, energy demand will change. Similarly, benefit, it will help to grid operators to maintain the proactive decisions for the load balancing. So when the load more, when the load will be less. So load balancing for renewable energy planning also very important. So this will be done by the weather predictions through AI in terms of energy management. Now, short term versus long term forecasting. Short term forecasting, that means focus on only on daily demand fluctuation. That is short term. Application, we can manage real time grid management and renewable energy output adjustment. Long term means we have to predict the demand. That means whatever the energy demand will be there over the months, over the years. Like application capacity planning and energy storage investment and policy making. So this is the difference. Short term may rely on real time data and immediate factors, but long term consider the macroeconomic and seasonal trends data. So short term and long term, we can see here, these are the labor needs, resource requirement, that is term week months, forecasting long term monthly years. So long term predicts the growth trends capacity, short term predict the resource requirement, how much resource will be required, that is the very important. Now we'll see one case study, AI powered load forecasting in the US. So we can get it, this is the AI technique, we use deep learning and time series analysis, they improve the forecasting by 20%. They reduce the operational cost by optimizing power plant scheduling, enhance the grid stability for predicting the demand surge more accurately. So this case study we can say AI driven load forecasting help particularly for utilize the manage the demand efficiently and they save the cost. That is the main. So in the large US utility they implemented AI based load forecasting model. Another, the solar farm they use for AI for weather forecasting. Location solar farm in Australia, unpredictable weather patterns are there affecting the solar output, so they implemented AI model for forecasting weather and solar conditions. So improve energy output planning accuracy by 25%, reduce the reliance on backup power, optimize solar energy storage and distribution. So AI enable solar forecasting, improve the renewable energy integration, and by that way they reduce the cost.